Should be 5.4, which is reference angles. If you want, have somebody go up to the front of the classroom where I keep all these copies and grab one of these classworks that should look like this, and then we can start. So 5.4 reference angles. You can do this warm up. Um, you see, pause the video, think of all the terminal coordinates that you know off the top of your head, and then resume it when you've written them down. So the terminal coordinates that you should know, right? The obvious ones are 1 comma 0 and the 0 comma 1s. And they could be negative 1s as well. I'm just not going to write them all down, but you can have plus and minus 1, 0 and 0 and plus and minus 1. Those are for your quadrantal spots, so they kind of like every 90 degrees. But then you also have the 45-degree ones are root 2 over 2 and root 2 over 2 as the y coordinate as well. And hopefully these all sound pretty familiar. Some of you may have the whole thing memorized at this point, which is good. And again, these could be plus and minus 2 depending on which quadrant you're in. The other two combinations of numbers you could have with the 30, 60, 90s would be root 3 over 2 and 1/2. And it could be plus and minus any of those. And then with your 60-degree triangles, it would just be those ones but flipped. So, plus and minus 1/2, plus and minus root 3 over 2, depending on which quadrant you're in. And that would be all of them, right? Those are all the ones that are created from special right triangles, and then your quadrantal ones right there. All right, so today's lesson, just a quick definition for you. Reference angles are quadrant 1 angles, but they have to be between 0 and 90 degrees or 0 and pi over 2 radians. And, if you're thinking that has to, like quadrant 1 angles have to be between 0 and 90, well, if you think about the angle 370 degrees, right, that would be all the way around and then another 10 degrees. That still spits you out in the quadrant 1, even though it's not between 0 and 90. So just keep in mind as we go through this, just because it's in quadrant 1 doesn't mean it's a reference angle. A reference angle is something that has to be between 0 and 90 if you're talking degrees, or 0 and pi over 2 if you're talking in radians. So what we want to do is basically think about other parts around the unit circle where the angles are not reference angles, but you can think of them in terms of reference angles, right? So 30 degrees is a reference angle. It's between 0 and 90. And if you think about what 30 degrees looks like, right, if you have a unit circle, and we can even draw, the lines in for our axes, right? But 30 degrees would look like this. But in terms of other angles that could have this same angle as a reference angle, it's basically like which other angles would create this same right triangle but in the other quadrants, right? And if you think about that, you think, okay, this angle over here would, right? And then this one in quadrant 3 would, and you kind of have that same bow tie shape that we found back when you guys did that exploration of all the reference angles to begin with. So you'd have all the other angles that have reference angle, right? This one here is your 30, but this one here, 150 degrees, would have the same reference angle as 30, meaning it kind of creates that same looking triangle. And then, if you went over to this one right here, that's 180 degrees straight across, plus this other 30 would be 210 degrees, would have the same reference angle as 30 degrees. And then essentially all the way around until you get basically 30 degrees below, so negative 30 degrees, but probably the way I drew it, this would be 330 degrees that way. So all of those have 30 degrees as their reference angles. And it's a nice, easy way to do it. If you want to just kind of figure out what other quadrant 2, 3, 4 angles, and they have to be between 0 and 360 degrees. So let's take 10 degrees as a reference angle. So 10 degrees is between 0 and 90. So if you're thinking quadrant 2, how could I get that? Well, for quadrant 2, start with 180 degrees, which is straight across, right? And then just subtract that 10 degrees off, and then you would create that same triangle that way. So that would be a 170 degrees if you did it that way. For quadrant 3, you basically would do the same thing, start with 180, but then add that 10 degrees, and then you would create the same triangle, but now it would be in quadrant 3. So if you do 180, when we'd add 10, we'd have 190 degrees, which also has 10 degrees as a reference angle. And then finally, for quadrant 4, we can take all the way around, take 360, and then just subtract off the reference angle, and then you would get the quadrant 4 spot. So in this case, it would be 350 degrees as your reference angle. And that would be all three of them, right? So it's pretty easy math when you think about it. You do 180 plus the reference angle, 180 minus the reference angle, 180 plus the reference angle, 360 minus the reference angle. And obviously, if it's in radians, you're going to use pi and 2 pi instead of those degree numbers. So quick on your own problem. I want to know pi over 8 is the reference angle. Find all of the quadrant 2, 3, and 4 angles between 0 and 2 pi that have that pi over 8 as its reference angle. Do that, pause the video, and then resume it when you're done. Okay, so quadrant 2, with the degrees, we did 180 minus the degree number, but instead of 180, we have pi. So I'm going to do pi minus pi over 8. And if I get a common denominator, 8 pi over 8 minus 1 pi over 8 would be 7 pi over 8. Quadrant 3 would be pi, same thing as 180, plus pi over 8, which would end up being 9 pi over 8. And for quadrant 4, we would start with 2 pi, or 360 degrees, and subtract pi over 8. So 2 pi is 16 pi over 8, minus 1 pi over 8 would be 15 pi divided by 8. So all three of these have pi over 8 as their reference angle. And then basically, so what we've done today is, I'll give you the reference angle. You find the quadrant 2, 3, 4 angles that have those as a reference angle. And then I'll give it to you the other way, where I'll give you a non-reference angle, and you have to find the reference angle. So a typical problem like this, if I had 325 degrees, right, that spits you out in the quadrant 4. It's definitely not a reference angle. However, itself, it does have a reference angle itself, right? So again, 325 degrees, this is 270 plus 55. It's going to be like right there-ish, maybe. So let's say that's 325. So where in quadrant 1 would I create this same triangle is essentially what you're asking yourself, because that would be the reference angle. So, I mean, this kind of definition is like, you just keep working with 180 until you get something between 0 and 90. It's kind of honestly how you can think of it. So, like if you have 325 and you subtract 180, that gets you to 145. Well, 145 is still not a reference angle. So then if you subtracted another 180 degrees, that would get you to negative 35, which would be the same thing as what you started with. And essentially, if you end up with a negative number that's in quadrant 4, just make it positive, because then it would be in quadrant 1, and then it would be your reference angle. So that's, it doesn't really go through that here, but that's an easy way to do it. So just keep subtracting 180 until you either get something between 0 and 90, or if it's negative, between 0 and negative 90, then just make it positive, and it has to be in quadrant 1 as a reference angle, right? So this would give you negative 35, which, making it positive, would be positive 35, which is the answer. The way this goes through it, and that's fine if you remember it this way, if you subtract 180, you get to the 145. It doesn't want to subtract another 180 because then it knows it's negative, so it just flips the order. It says, okay, we'll start with 180 and then subtract 145, and then boom, you get your 35 that way. I don't really care. You could even start with 360 and subtract 325 and do it that way. But if you only work with 180 and 360, you will get it eventually just by doing subtraction. You don't want to work with 90. That's going to throw you off. But the 180 is straight across, and 360 is the same thing. 90 is going to change it up a little bit. So you get two quick ones on your own here. Try and find the reference angle for both of these angles. Pause the video and resume it when you finish. All right, so if you did 4 pi over 3, right, it's kind of the same thing, but it's in radians now. So instead of subtracting 180, we're going to subtract pi, because that's the same thing. So 4 pi over 3 minus essentially 3 pi over 3, so you have a common denominator, is just going to be pi over 3. and that is the reference angle. Notice about pi over 3, it's 60 degrees. It is in quadrant 1, so you're good. Negative 400 degrees, you could do this a few different ways. You could add 180 and add 180. You could add 360 directly to it, though. And just say, okay, if I added 360, that gets me to negative 40. And then that's that same argument, right? Negative 40 is a negative angle in quadrant 4. So if you just made it positive, it would be positive 40 in quadrant 1. So the answer is positive 40 degrees. Or you could have, added 180 and then gotten to like 140 again. Like if you took this, added 180, get to 140, and then do 180 minus 140, that would get you to 40 back. I'm sure however you got it, if you got 40, you did it right. And then last things that we want to do today is the goal is to kind of write things that are not expressed as reference angles in terms of sine and cosine, and even other angles too, tangent, cotangent, all that stuff. Write them as reference angles. And then if you can evaluate it, then go ahead and evaluate it. But like right here, cosine of 135, right? So there's two things. You need to worry about cosine, you need to worry about 135 degrees. Since it says express as a reference angle, find the reference angle first. And if you look at 135, you say, okay, 135 degrees. How could I find the reference angle? Well, if I did 180 minus the 135, that gets me to 45 degrees. So 45 degrees is the reference angle. So I need to express this as a reference angle. So you say, okay, well, it must just be cosine, since it says cosine, of 45 degrees. But that would be a little bit of a problem because cosine of 135 and cosine of 45 are two different answers, right? So if I did cosine of 135, and I need to make sure I'm in degree mode, which I am, gives me, and we probably, if you know it, it's negative root 2 over 2. It's the x-coordinate at 135 degrees. So negative root 2 over 2 is the same thing as negative 0.7071. And if I did cosine of 45 degrees, you might know that as positive root 2 over 2, so positive 0.7071. So they're not the same thing. So this is not your answer because this is not the same thing as this. So why is one negative and one positive? So if you think about 135 degrees, the cosine of the x coordinate, it's negative right here. And then if you wrote it as 45 degrees, the x would be positive. So you need to somehow adjust the fact that this is a negative x and this is a positive x. So what you need to do is say, okay, this answer is going to be negative. If I wrote it as cosine of 45, it's positive. So if I throw a negative sign on the outside of this, now this is exactly the same as cosine of 135, right? So we have cosine of 135. The answer should be this. So if I just put a negative cosine of 45, then it would be the exact same thing. So this is writing cosine of 135 as a reference angle, right? Because the only difference is now it's 135 it's 45 instead of 135. So to make it sure it's equal to the same thing, you have to throw the negative sign out there. But, I mean, it doesn't work the same for everything, right? Right, those are the steps we just did. But if I did sine of 135, right, you think about 135 degrees for sine, sine is the y-coordinate. So right there, 135 degrees, the y-coordinate is positive, just like it would be at 45 degrees, which is the reference angle, which is still positive. So if you had to write sine of 135 as a reference angle, you'd say, okay, there's no sign change, right? There's no change from negative to positive like there was with cosine. It's positive y here, it's a positive y there. So literally this one's just as easy as saying, okay, that's sine of 45 degrees. It is the exact same thing as sine of 135. Right, so sine of 45, and then sine of 135. And they will both give you root 2 over 2. And those are equal. So quick on your own problems, do the express sine of 170 and cosine of 170 in terms of reference angles. Keeping in mind this isn't going to be like a root 2 over 2. 170 is not going to create a special right triangle. So you can't do anything with that. You would just express this in terms of its reference angle. Pause the video and start it when you finish. All right, so sine of 170, it's kind of similar to the 135. It's just going to be, the reference angle is, if you found 180, if you did 180 minus 170, you get 10 degrees. All right, so this would be sine of 10 degrees, and that's it. There is no sign change that you need because at 170 degrees, the y is positive, and it's the exact same values as at 10 degrees, so there's nothing that you need to do here. But cosine of 170, that is negative because the x-coordinate is negative. And the reference angle still has to be the same. It's going to be 10 degrees. But because cosine in quadrant 2, which is where 170 lands, is negative, and in quadrant 1 it's positive, you need to throw a negative sign on the outside to make sure that this is equal to this. And that's it. So your quick summarizer, it's a 3-2-1 summarizer. If you want to do this, go for it. Once you are done with this summarizer, you can go ahead and start the homework. If you have somebody else that wants to hand out the homework, you can. Maybe you already have it. I'm not sure. But that's it for today's lesson. Thanks, guys.